There are four failure layers. Retrieval failure, which is the system can't even access the information which it needs. Context failure, it misreads the situation. Reasoning failure, it can't process the information logically. And verification failure, it can't confirm whether its own answer is actually correct or not. The traditional pipeline is just two steps: retrieve, generate. The modern one is five: retrieve, evaluate, plan, generate, and verify. So, step one, retrieve from the knowledge base. Step two, run a retrieval evaluator to score the quality of what come back. Step three, if the quality is weak, retry, refine, or expand the search. Step 4, filter out the noise and keep only the useful evidence. And the final step, generate the answer from the improved context. The system retrieves on demand, generates an answer, reflects on its own outcome, and improves the response when it needs it. I'm gonna give a quick brief around what's there, who I am, and it's Aditya. I basically run a company, CreateBytes, Yugyog.ai, Cricket, Alteryx Labs. We are situated across the globe from US, UK, Europe, and other places, and we've been building a lot of products in AI domain. We initiated this activity and we've been publishing videos since the last few months around how the webinars can give us a very strong fundamentals in a right direction. In order to do the same activity, we are gonna basically get into a very interesting topic today, which is RAG systems at scale and beyond the normal RAG, which is important. And read the title because it's important, which is beyond traditional RAG. I would like you to hold on to that word, beyond. Most of the time, when you're gonna go online and look into RAG tutorial, what happens is they get into the basic side of the thing, which is embed your documents, pull the top matches, paste them into a prompt, generate an answer. That's the plumbing, and the plumbing is the easy part for RAG. What separates a weekend demo from a product people pay for is everything that comes after retrieval, which is evaluating it, reflecting on it, that how you've built it, verifying it. And that's the journey this whole deck takes you on, from retrieval to evaluation to reflection and then verification. If you only ever learn the retrieval and generation loop, you're already a couple of years behind where the industry actually is right now. And by end of today, you'll be standing on the 2026 line for the same. Okay, and it is critical that you do it. Hope my screen is visible, and I'll be able to jump towards the next section. And now, this is critical and important, that what exactly it is. So let's start with why RAG exists at all, which I've explained it in past too, because the slide lays it out cleanly. Before RAG, a model's knowledge was frozen on the moment training ended. It couldn't see your private documents, it couldn't see anything recent, and the only way to update it was an expensive retraining cycle. RAG broke that open with one simple move. Instead of cramming all knowledge inside the model, you retrieve the right evidence at the moment you need it. Query and retrieve and generate. And look at what it unlocks if you do that. Like if you see on the slide, there is dynamic knowledge that's always current, enterprise search over private data, grounding in a specific domain, and far fewer answers pulled out in the air. And that is important. This is why every company suddenly wants a chatbot on their data. That chatbot is a RAG system. What's the good news here? You don't build this from scratch. Frameworks like LangChain and Llama Index give you the retrieve generate skeleton in a few lines. So you spend your time on the hard parts, which we are about to cover. And that brings us to why RAG became the standard. And because of this one shift, which we talked about, RAG showed up everywhere. The slide lists some of the scenarios where you have customer support, legal assistance, internal knowledge search, search assistance, healthcare, and other systems. If there's any question, the team will be able to answer. I think there are some people if who are raising their hands. They can chat through and the team can answer while I'm explaining the overall direction for us. So to a business person, these looks like five different products, And to an engineer, they are the same pattern wearing different clothes. The key idea is at the bottom, and it's like try to understand this line. Instead of storing everything inside the model, you retrieve the right evidence when it's needed. Learn that one pattern well, and it travels across every industry on the slide. And I'll give you a real example from our side. Okay, so we are basically building a powerful agentic system for doing a lot of extraction activities in a medical domain. And when it happens, it basically give us factual grounded data. And the way we have done it, that's the thing which I'll be explaining through practical examples to you today. Okay, what's a traditional RAG architecture? So there's a like if you look at a very traditional pipeline, user query goes to the retriever. The retriever returns the top K documents. Those go to the large language model and comes up with the answer, which is clean and simple. But notice that the slide calls the core assumption that the retrieved context is relevant, sufficient, and reliable. Three quiet assumptions baked into one arrow. And this is important. Okay, understanding it. Slide is honest about what happens next in production. That assumption often breaks, and it's important to know why. And the rest of the deck is really just a careful look at how it breaks and what to do about it. Okay, a habit which we should worth building internally. Whenever someone shows up an architecture diagram to you, you need to always think about what's the weakest assumption here, which the person has taken in their architecture diagram. On this one, the answer is that retrieval is being trusted blindly. Whether you are basically using Pinecone, or you're using Quadrant, or just Chroma on your laptop, the diagram is identical. And so the weak spot we need to know is something which we just like let's say anytime you're retrieving, you're thinking that yeah, it's trustworthy and identical. That is a big assumption which you've taken. And that's where most of the time we just ignore. And again, as always, think about if I increase the size of the model, everything will improve. That is not the case. Now, it's important to understand, because now that the deck gives you a very high level map of where things go wrong, and it's worth memorizing because it organizes everything that follows. There are four layers. Retrieval failure, which is the system can't even access the information which it needs. Context failure, it misreads the situation. Reasoning failure, it can't process the information logically. And verification failure, it can't confirm whether its own answer is actually correct or not. And now look at the panel on the right, the inverted funnel. These stack on top of each other. And then read the line that really matters. Many of these failures begin before even generation starts. The single sentence is the whole point of this session. You cannot fix missing evidence with a clever prompt or a bigger model. Reliability is a system design problem, which we need to understand. And keep this in your mind that prompting alone or like just switching a bigger LM cannot fix missing evidence. Okay, the they your stakeholder or client or with whosoever you work with, that person says just tweak the prompt a little and it will improve. You'll know when the problem is living and the prompt can't change it, and it is important to know about it. Okay, now, let's discuss some failures. So let's make the first failure concrete, exactly as the slide does. Someone says, what are NVIDIA's Blackwell specification? Do you guys know what is NVIDIA Blackwell? So NVIDIA has very powerful GPUs called as H200, H100 GPUs. And then they launched about, I think, one and a half year back called as Blackwell architecture, where NVIDIA has B100, B200, B300 GPUs, and even there is this commercially available NVIDIA GPU called as 5090. They are all Blackwell architecture. So Hooper architecture was earlier being commercialized, and NVIDIA came up with a much more efficient architecture, which is Blackwell architecture. So that's what Blackwell is. NVIDIA is Blackwell. So these are servers with NVIDIA B100, NVIDIA B200, NVIDIA B300 GPU. So what are NVIDIA's Blackwell specifications? The system goes and retrieves Hooper architecture documents, CUDA documents, some older benchmark summaries. All of them are real, all of them are related, but the one thing that's missing is the actual black belt document. And here's the result. The slide immediately shows you that even a stronger model produces a wrong answer when the key evidence simply isn't there. So the common cause which are listed are missing documents, weak embeddings, poor chunking, bad re-ranking. The model was never the problem here. The pipe that feeds it was the problem. So what is your debugging rule number one? When an answer is wrong, look at what got retrieved before you touch anything else. Very, very important. Most of the time, you'll find retrieval was the culprit. And in 2026, the standard fixes that are embedded layer, strong embedding models like OpenAI's text embedding 3, Cohere Voyage you can use, plus Anthropic's contractual retrieval trick, which attaches a little surrounding context to each chunk and has been shown to cut the retrieval misses by roughly half. So this is again important, and this is one of the failure reasons. Now, why retrieval phase? Let's get into the patterns behind that failure, and each one is worth recognizing one small bit in a step-by-step direction. So one is systematic drift. The query and the result are about the same topic, but the result doesn't actually answer the question. Vocabulary mismatch. You search car, the document says automobile, there are chunking errors which come in after that, which are like an important fact. Okay, let me first give you the high level idea when I say that we have these retrieval failures and why they fail. You've seen what happens when you retrieve, and I don't need to get into the explanation of it, but like at a very high level, when I say chunking errors, there's an important fact that get split across two chunks, so neither one is complete, and it is important to understand this part. Okay. Then there is ranking errors. The right document was retrieved but ranked so far down the model which never looked at it. Okay. And knowledge gaps. Again, another reason. The answer just isn't in your corpus. And notice the difference in the last one. The first four, you can engineer your way out. The last one demands honesty. The system has to be allowed to say, I don't have this, and it is important. So two of these have uh, clean tooling answers. For vocabulary mismatch. Run hybrid search like keyword, which is BM25 kind of keyword search, and vector together working, which is the production default now that you should use a hybrid search with keyword and vector. For ranking errors, add a re-ranker on the top, like Cohere re-rank or an OpenBG, which will quietly lift the right document back to the top. And for chunking, try the semantic chunkers in Llama Index instead of slicing every 500 characters blindly. And it is important to know. Now, let's talk about the failure two, which is incomplete context. The second failure, and this one is sneaky. This is basically someone asks, can I cancel my subscription? The system retrieves the refund policy, but the cancellation policy is missing. Now read the line in the middle because it's the heart of it. The model treats the available context as if it were the complete context, and it has no idea whether anything is missing. So, what comes out, as the slide says, is a confident but incomplete answer. And a confident wrong answer is the most dangerous kind because nobody thinks to double check it. Okay. And this is the failure that never shows up in your demonstration and shows up constantly in the production. The fix is a completeness check before your answer. And I'll show you in the self-reg section how the system can ask itself, did I actually cover everything this question needed or not? Now, let's get into the failure three, which is weak reasoning. Third failure moves us past retrieval entirely. And this slide explains, compare AWS, Azure, and GCP for a fintech startup, where the information almost certainly exists. That's not the hard part. The hard part is it is interpreting it across cost, compliance, scalability, and risk. and then it draws the cleanest distinction in the whole deck. Retrieval answers what evidence exists, but reasoning answers what the evidence implies. Two completely different skills. You can have a perfect retrieval and still have a useless answer if the reasoning is weak. The and try to understand this. The tell is the verb in the question find, look up, what is, these things. That's a retrieval task. Compare, recommend, should we. That's a reasoning task. And a single retrieve then generate pass will never do a justice to it. These questions are where you start researching and reaching for reasoning focused models and multi-step plan, and not just focus on bigger top K methodologies for doing it. Okay. And now I'm going to go towards the fourth failure, which is again, and everything which I'm talking about is pure production scenario. The fourth failure is the one everyone names, but a very few people diagnose it in the proper direction, which is hallucination. The slide traces where it actually comes from, and it's a chain. Weak retrieval leads to a weaker context. Weaker context leads to a weaker grounding, and weaker grounding produces a confident output with nothing real underneath it. And that's the hallucination. The important nuance is at the bottom. The same symptom can come from retrieval error, a reasoning error, or a generation error. System, there's symptom, and then there are three possible routes. So the AI hallucination isn't a diagnosis, it's the start of one particular scenario. And this is important to understand. So when a client says your AI is making things up, your job is to trace which link in that chain snapped. Applying a retrieval fix to a reasoning problem just burns the whole week and you won't be able to solve it. So trace first and then fix it second. It's important how you should be diagnosing these production systems in that scenario. Now, let's try to understand. And in the diagnostic checklist that tries let's say that ties the failure 11 and let's say 12 together, three sources of wrong answer can come. A retrieval error, the evidence was wrong or missing. A reasoning error, a wrong conclusion drawn from evidence that was actually fine. A generation error, a claim the evidence simply doesn't support. Then the key idea, which is the most useful single sentence for your career. The fix depends upon the source. Better embeddings will never fix a reasoning error. Diagnose it first, then choose the corresponding medicine to fix it. And say this triage framework out loud in any interview. Whenever you sit in an interview, I identify the failure source first, then map the fix to it, and you'll instantly sound a level above the candidate who just say, I'd improve the problem. That sentence is worth writing down right now. If you guys are there, I'll say it again. I identify the failure source first and then the fix to it. That's important. Now, let's basically move towards what traditional RAG is missing. Okay. And before we do that, I'm going to take a quick break and let you guys ask if you have any questions before I jump towards the next section. So, like, you guys can get a quick chat enabled, and you guys can ask a question. And yeah, I think the team can give you an access for you to chat, and I can see the questions. Any questions, guys, you have before I proceed further? Very, very important topic we are covering today. Once you are able to use it, you can actually start, like, once you say it to anyone, it will be better than anything which you can talk in an interview going outside. It is very, very, very powerful. Okay, I'm gonna proceed further. Okay, now, so if traditional RAG breaks in all three ways, was the one thing it is missing? The slide answer is very simple if you look at it, which is evaluate. The traditional pipeline goes and retrieve, then straight to generate with nothing in between. It never pause to ask the question on the slide. Is the evidence sufficient? Is the retrieval reliable? Should I search again? Should I narrow or expand the query? A system that never asks these is essentially answering with its eyes closed. Adding that one evaluation step is the difference between a junior system and a senior one. And you don't have to eyeball this. There are whole evaluation frameworks now built for exactly these questions. There is Deep Eval, there is Phoenix, there is TrueLens. They score your retrieval and your answers on relevance, faithfulness, and completeness. So, is my evidence good enough? Becomes a number you can actually track and not a gut feeling. Now, what is the difference between a traditional versus a modern AI pipeline? Now, the deck puts the old and the new side by side, and the contrast says everything. The traditional pipeline is just two steps: retrieve, generate. The modern one is five: retrieve, evaluate, plan, generate, and verify. And the four pairs underneath summarize the whole shift: static versus adaptive, one pass versus multi pass, no reflection versus reflection, no validation versus validation. A modern system doesn't answer in a single shot, it loops, it checks itself, it earns the answer. In 2026, the style has a name, which is called as Agentic RAG. And the way you build those loops in practice is usually with LangGraph, which let you wire retrieve, evaluate, generate as a state machine that can go backwards when it needs to. And one honest warning to pass on, though. These loops can burn several times the tokens in a plain basic pipeline. So the real skill is setting a stop condition, a maximum number of retries, and a confidence threshold. So the system knows when to quit. A loop without a stop condition is just an expensive way for timeout, which is very, very, very wrong. And we need to make sure that we do that. Now, this particular slide drives the point home by listing the actual decisions a modern system makes before it answers. Is retrieval sufficient? Is confidence high enough? Is the evidence contradicting itself? Should I search again? Can this answer even be verified? And then the line that I'd frame on a wall: modern AI systems are not just generators, they are the decision system. There's the mental shift what you want to leave with. This is the philosophy underneath it. The most practical versions of this in 26 is adaptive RAG. And when you put a small, fast classifier in front that reads each query and routes it, easy questions get a direct answer. Hard ones get the full multi step treatment. And you stop paying for a heavy pipeline on questions that don't need one. And you need to ensure that you match the effort to the difficulty score, and it can become very, very powerful when you use it. Now, now we get to the two big upgrades the rest of the like platform is needed and is built around. And the slide introduce both with flow and a clean summary. Trace the flow runs: query, retrieval, evaluator, then correct, retry, or refine the retrieval. Then generate it as a draft, check it out for relevance and support in a self reflection layer. Retrieve more if needed, refine, and only then give the final grounded response. And the key idea at the bottom is the cleanest way to remember the difference. Corrective RAG improves the evidence before generation. Self RAG improves the answer through reflection during generation. One fixes the input and the other fixes the output. And that one line distinction: CRAG fixes the input, self RAG fixes the output, is a very classical interview question, and you guys should know about it. Have the answer loaded before you walk in any interview. Okay. Now, how self-corrective RAG works. Okay. Let's try to basically understand this diagram. Uh, it's basically something where you can see from left to right, because it shows the loop in the action. A question comes in and hits a router. Flow one is document search, which is retrieve, then grade what you got. If the grade comes back incorrect or ambiguous, the system doesn't just push ahead, it drops into flow two. An external web search comes in the picture to go and find the better evidence. Then everything moves to generation, and finally to a hallucination and quality check. If the output is grounded and relevant, it becomes the final answer. And let's say if it's a hallucinated one, it loops back around. Notice that this is not a straight line. These dashed arrows are looping back, are the whole idea. That feedback is what self corrective actually means. That grade node and that quality check node, if you see that, that's the evaluator, which is when I was describing, which was just drawn into the picture. Different name, same job, but don't trust and ensure that you verify it. If you want to build this exact graph, LangGraph ships CRAG and self-reg references in the templates itself. So we'll push a small code base on Git where you will be able to see LangGraph has the CRAG self-reg which is being shipped with it in its reference templates. And you can start from instead of writing it from zero, and I'll basically share the GitHub repositories for it so that you can use it. So that these things become very powerful. Let's now isolate what corrective RAG actually adds, which the slide does by stacking the two pipelines. Traditional is retrieve, then generate. Okay, it's important to understand when you're doing some sort of basic ones. Now, I think you will be able to see beyond that, but generally it was just retrieve and generate. Corrective is retrieve, evaluate, correct, and then generate. Three concrete changes follow. Retrieval is no longer blindly trusted. The retrieved documents can be checked before they're being used, and weak retrieval can trigger a better search pass. In a very simple language, you've given the system a way to notice it, which fetch the garbage, and a way to try it again if that's the case. The most useful piece in real system is what fallback is. When your internal knowledge base comes up weak, drop to an external web search. We do exactly this in production. Internal first, web search as the safest net. It's a small addition that saves you from confidently wrong answers on the questions your own data never covered. And it's important to know about it. Now, let's basically get into the corrective RAG workflow. Here's that the same idea as a step-by-step workflow can basically bring it up for you. So step one, retrieve from the knowledge base. Step two, run a retrieval evaluator to score the quality of what come back. Step three, if the quality is weak, retry, refine, or expand the search. Step four, filter out the noise and keep only the useful evidence. And the final step, generate the answer from the improved context. The thing I want you to notice, generation is the last step, not the first. Usually, when we are building the very first RAG, we just rush it to generate the answer. The whole craft here is cleaning the evidence before you ever ask the model to speak and say something that this is your answer. That retrieval evaluator in step two doesn't need to be a very fancy one. A small, cheap, large language model called, are these documents enough to answer this query? Yes or no, and why? Gets you most of the value. If you want it faster and cheaper, cross encoder relevance scorer does the same job without a generation call. And it is important to know about it. And this is also part of the GitHub repo, which is cross encoder relevance scorer, which is going to be part of it. Now, this slide basically collects the payoff of what are the advantages. How, if I do this, what are the payoffs for me? Okay, corrective RAG improves retrieval robustness, reduces noisy or misleading context, increases grounding before generation, can reach for external search when the internal store is weak, and my favorite line on the slide, works as a plug and play upgrade to existing RAG systems. That last one matters more than it looks because you don't have to tear down what you have already built. You bolt a correction layer on top and the whole thing gets more reliable. That plug and play framing is gold in, let's say, a production conversation or client conversations. This is very important. We won't rebuild your system. We'll add a correction step on top of it. We lower your skip, we lower your risk, and we are gonna make sure that your shipping becomes faster and visibly better result. That sentence wins a lot of projects. Like DRY, don't repeat yourself. follow the solid principles, open for extension, close for modification, just scale it up. That's it. Now, what is self-RAG? Okay, the slide defines it. Self-RAG means self-reflective retrieval augmented generation. The system retrieves on demand, generates an answer, reflects on its own outcome, and improves the response when it needs it. Look at the simple flow. Retrieve if needed, generate, reflect, improve, respond. And linger on those two specific words if needed, because they are the upgrade. The system doesn't retrieve on autopilot every single time. Sometimes it already knows the answer, and a retrieval will just be wasted of cost and latency. Retrieve if needed is the adaptive decision again, just inside the answer loop. Hitting the vector database on every trivial query is huge tax on speed and budget. And a system that can choose not to retrieve is one that get the respect for both the speed, the latency, and the cost scenarios. Now, let's get into a self-RAG architecture. A question first comes in. First decision: is retrieval even needed? If yes, retrieve the evidence and generate a draft, then reflect on that draft's relevance and support, and retrieve more if it is lacking. Regenerate a better answer, and then return the final response. And the slide names the core shift in a very beautiful direction. The model doesn't just answer, it also judges whether its own answer is good enough, and it grades itself. The self grading loop is the entire heart of a self RAG. And that thing, which is judge yourself, loops, and like try to understand part where we are saying judge yourself. That loop sounds advanced, but the code is very, very approachable. It's a state machine and a LangGraph, which is basically a natural tool for it because it handles the loop back and revise the flow cleanly. The concept is basically a little tough, but the implementation is like, let's say you sit for 6 hours and that is it. And I'm gonna add this too in the GitHub repo so that you guys can look into the GitHub repo and see how it works. Now, this is interesting. So this slide explains the clever mechanism that makes self-RAG work, which are reflection tokens. The original method trains special tokens that let the model control its own retrieval and critique while it is generating. And the slide tells you what those tokens are really asking on the model's behalf. So do I need retrieval? Is the evidence relevant? Is the claim supported? Is the answer useful and complete? And think about it. Picture it as a small inspector sitting inside the generation process, raising its hands whenever something is off. So you'll probably never train reflection tokens yourself, but the concept is the takeaway, not the implementation. You can recreate the exact same behavior with a separate critique model or a structured prompt that asks those 4 questions after each draft. Borrow this idea, choose whatever implementation fits your stack, and just use this. But understand those reflection tokens. Now, how a self-RAG actually thinks. Think about it. As the slide says, that answer directly or retrieve first. This is important. Keep the current evidence or get to, let's say, more of those evidences. Continue the draft or revise it. And always prefer the version that's better supported by the evidence. What is the result? At the bottom, it is basically the 3 word worth holding up, which is the system becomes adaptive, controllable, and evidence aware. If you ever need to define reliable AI in one single sentence, okay, or let's say some words, and these are 3 words which you can use, which are adaptive, controllable, and evidence aware. And that's how a self-RAG thinks. Okay, and you can say this in your interview too. I built an adaptive, evidence aware retrieval system. Why? How did it happen? Because it chose whether I should answer directly or I should retrieve first. It chose keep the current evidence or get to more evidence, because it chose continue the draft or revise it, because it chose always prefer the version that's better supported by evidence via choosing the 3, 4 scenarios. And that's why you can directly say I built an adaptive evidence aware retrieval system. And this is something which a lot of technical folks will understand, that you have a good knowledge of how 2020 system works. Now, uh, like let's get into the traditional RAG and adaptive RAG scenarios and the advantages. Okay, so traditional RAG retrieves in a very fixed way, same process for every query. Self RAG retrieves on demand, shaped by what the query and the evolving draft actually need. The paper calls this adaptive retrieval, that tailors its behavior to the task. Why it matters, as per this slide, and understand it. A better fit across different question types, smarter use of retrieval, and a more flexible generation. And it is the difference between a system that follows a script and the one that is basically present inside in a very normal direction. The idea collides with a big 2026 debate, which is, I feel you guys should know about, which is RAG versus long context. So context windows are huge now, into the millions of tokens. So people ask, why retrieve at law? If I have million of token context window, why do I need to retrieve and why do I need to use RAG? Just paste everything in it and it will be done with it. The grown up answer is to combine both of them. Retrieval finds the right material and the long context does the heavy reasoning over it. Important to understand. Okay, don't just rely for retrieval 2 on the long context. So they are partners and they are not rival to each other where you use one over the other. Use both of them together. And the strongest system this year uses both of them and achieve the max which a system could have practically achieved. And that's the idea. Now, again, there is another thing which is there, which is factuality. Okay. Uh, this slide reports that by pairing retrieval with self-reflection, self-RAG significantly outperforms strong large language models and retrieval baselines on factuality tasks. An important one. Translate that into what you can care about. More grounded claims, better use of evidence, and most trust in the outcome. And factuality isn't a luxury feature. In legal, in healthcare space, in defense, a strong confidentiality uh, scenario can help in terms of ensuring a better contract, and you can rely on drafting of that too. And it is important to know this in a very detailed manner. So let's say you take an example of a legal or a defense framework. Factuality is simply non-negotiable. One wrong citation and we are done. That's precisely why we add self-reflection layers instead of trusting a single pass. The more serious your domain is, the more these checks are going to be present, so that you're not going to do something which is not at all part of the overall qualitative answer. Okay. And then we need to have some sort of better support checking. Okay. Self-reg doesn't only generate answers, it checks whether each generated answer is actually supported by the retrieved evidence using reflection signals like relevance and grounding. And the payoff is listed in a very plain language, which is better grounding, fewer unsupported statements, stronger alignment between what's claimed and what's in the evidence. In everyday language, the system keeps asking itself, is what I just said actually baked by something I retrieved? If not, that claim is not going to survive. And you can enforce a lightweight version of this by hand. Require a citation alongside every sentence which the system produces. If the model can't point out to a source for a claim, treat that claim as a suspect. It's a simple discipline that catches a surprising amount of nonsense before it reaches the user. And that's why self-RAG has a better support checking too. Again, another interesting thing, which is better completeness. And this is something which is very, very critical. And it's the fourth one. And this one closes the loop on a failure, which we saw earlier. Remember, if in our earlier slide, I think it was ninth slide, the incomplete subscription answer, and this is now fixing it. The slide says self-RAG can recognize when an answer is incomplete and then go retrieve more targeted evidence before responding, using its reflection loop to spot the missing pieces. And the benefits of this are huge. The better coverage of multi-part questions, fewer partial answers, more complete final responses, and is the system noticing its own gaps and filling them before it speaks? Multi-part questions, what is X and how do I set it up, are where basic RAG in a like, let's say, you the traditional RAG, I can say, rather than basic RAG, they are not giving us reliable answers and they will fail. A completeness check is the one that is giving a very clear signal of how the answers need to be present in a production system. Okay, and it is important, and definitely, like, when we are thinking of RAG, we just think, okay, can you retrieve me this information or this information? This is not how people are using it. When they're chatting, they may ask something, and then there are two, three questions and different answer folds, and where the completeness of the answer becomes very, very, very critical and important. Now, let's talk about a better, longer form answer, which is again an important part, which is basically, if you note that the self-RAG paper reports significant gain in factuality and citation accuracy, specifically for long form generation, which make it specially valuable for detailed expansions, research summaries, and extended answers. And that's the honest test of any system. Anyone can return a one-line fact. The real challenge is long, structured, properly cited answer that holds together from start to the very finish. For a long relationship heavy answers, the tool a lot of teams reach for in 26 is GraphRAG. Okay, you store your information in some sort of knowledge graph of entities in relation instead of loose chunk, so the connections survive. Microsoft's GraphRAG and graph stores like Neo4j are the common sharing points where relationships matter, which are, let's say, organization structures, legal precedents, supply chains. A graph beats flat vector search in a very interesting way, which is something which you can leverage and check for Microsoft RAG 2. And the slide reports that self-RAG outperforms strong baselines on reasoning and fact verification tasks. And the reason is right here, because it can retrieve, critique, and refine. It supports stronger multi-step answering. The benefits listed are better comparative answers, better multi-hop reasoning, better analytical responses. Think back to the AWS versus Azure versus GCP question from our earlier slide. This is the machinery that finally answers it properly instead of just listing the facts, but it checks for the different scenarios in which the three cloud platforms can be compared. Retrieval paired with genuine answers is the real 2026 frontier, and we should know this. Combining a reasoning focused model with a self-reflective retrieval loop is what's going to put you in the small group of people who ship serious production systems rather than just demonstrations and basic things. And that is why today this lesson was very critical and important. Before I jump into future more practical scenarios, I wanted you to get an idea of what is happening with RAG in 2026, because next topics are going to be much more powerful than this one. Okay, and then let's land the whole session in three lines. And this slide give us that. Traditional RAG retrieves evidence, corrective RAG improve the quality of that retrieval, and self-RAG improve the model checks, refines, and strengthens its answers through reflection. And that's the entire arc: retrieve, correct, and reflect. Three steps that take you from a fragile, naive system to a reliable one. If you remember nothing else from what we discussed, remember these three words and the order in which they are written: retrieve, correct, and reflect. Okay, that's it. And here's the one habit I want you to walk out with, and it is important that you do it. From today onwards, look at every RAG system and ask, is this thing verifying itself or just talking? And important for you to know that whether a system which you saw as a RAG, is it just giving you an answer, or it's basically verifying its answers. The moment that question becomes automatic for you, you have stopped being a student in terms of understanding basic RAG, and you've started thinking at a core production level engineering scenario. So whenever you go to a chat system moving forward which says I can retrieve, think about whether it is evaluating its answers and basically making sure that it verifies itself, or does it basically just do some sort of engineering? Okay, and it is important to understand. Now, this is something which I want you guys to do, because the next sessions are going to be much more powerful. It's important that you guys are consistent with this, because I'm gonna be jumping towards much more valuable production lessons, because we have been hiring a lot, and while we are hiring and then helping a lot of companies across the globe in terms of ensuring that how the products need to be built, I've seen a gap, and I want this gap to be filled by you guys and people who want to join in terms of not just going through basic fundamentals of like, okay, how it is, what it is, but actually thinking in production what happens. Like when you go to the production scenario, what happens. And we'll be doing very powerful offline conferences and workshops moving forward. And you guys should just be aware about it. Go to the WhatsApp community, look what is happening there, because there we'll be doing the announcement. It is going to happen in Gurgaon, and there'll be a lot of other big companies which are going to be coming in that session. And when you'll be there, it will be interesting for you to know what's happening, and then the new interactions which can come in. So follow the Instagram, join the WhatsApp community, get an idea. You can also learn a little bit about how and what CreateBytes is doing, and CBXperts courses which are out there. And the most important part is we doing the offline cohort to make you much more powerful engineer, and actually enter into the AI domain at a much more faster basis. Now, I'm gonna quickly stop right now and would love to see if anyone has any questions before we close the call. Type in the questions. Anyone? You wanna ask something? Yeah. Tell me, Raj. Uh, you guys can unmute and ask the question, guys, if you want to. Yuvraj, you can unmute. The host can give you. Okay. So, are we receiving anything on for attending? Yes. I think like the team will tell. You may have to send a message. Are you on Instagram? Following that, and what's your group? You'll your email IDs will be needed. Yeah, you'll be getting some certificates around it. What else? Okay. Instagram link. Uh, just scan this QR code, guys. Scan this QR code. When you join the community, there itself the Instagram link will be shared, or the Instagram link is already present. Scan this code and join the community. I'll wait for 5 minutes, and then yeah. Okay, I'm gonna come here now, guys. Any questions? Anyone? So Instagram link is also in the chat. So so I think on WhatsApp you'll get an idea. There's a process which you guys need to follow. Sarthak, do you want to explain how the process is? Like, where are you gonna inform it by tomorrow? Okay, perfect. Okay, guys. I think we're good for now. Thanks a lot. Good day. Bye bye, everyone.